issues surrounding the internal workings of the CPU. The computer has a central processing unit. The system bus are the wires on the motherboard that allow the central processing unit to communicate with the internal memory, the RAM, and the input and output devices, primarily the keyboard for input and the monitor for output. The central processing unit, the CPU, is the chip which consists of a number of transistors, switches, and memory locations, registers, and the memory is what is also referred to as RAM, or immediate access storage. So it's fast storage. The data that is stored here, data instructions are stored here, and they're volatile. All of it is lost when the computer is switched off. In the stored program concept, a program must be in main memory in order for it to be executed. The instructions are fetched, decoded, and executed one at a time. This is known as the fetch and execute cycle. We fetch instructions and data, we decode them, and we execute them, and we keep doing that. There are a number of registers. A register is a small amount of fast storage which is part of the processor. Some of the registers we will consider include the accumulator, which is a data register that we add data to, the program counter, which increments and it keeps track of the memory address of the instructions to be executed next. The memory address register holds the address in memory of the next instruction. The memory buffer register, which holds the data that's fetched from the memory, and the current instruction register, a temporary holding ground for the instruction that has just been fetched from memory. In our example of the fetch and execute cycle, we'll consider assembly language programming. We have instructions such as load, LDA, loading the contents of memory into the accumulator, adding the contents of memory, and storing the contents of the accumulator at an address location. The assembler level programming is the second generation programming language, and it uses mnemonics, easy to remember words, to take the place of machine code. Before assembler programming, all of this would have been done in binary, but now we've converted the binary into these very small, simple sets of instructions. Here we can see an example of the corresponding machine code. This machine code would consist of the instruction store and the address location 53 to store the data at address location 53, and this is the machine code. The instructions have two sections. We have the opcode, the instruction name, and the operand, the data or address. In this case here we have add the number 45. So the opcode is add a number and the operand is 45. We will now simulate adding the numbers 2 and 3. First of all, I'll put the data into memory address 16, 2, and into 17 I'll put the number 3, the data 3. In the first instruction, I'll put in the instruction load into the assembler, and into the assembler I will load the data at address location 16. That's going to be 2. There's the address and the data at 16. The second instruction will be to add, which is number 3, and I'm going to add the data at location 17. So I give it the memory address. Third instruction is to store the results at memory location 20. Then I will output the results, instruction 12. I'll output the results of the data at location 20, and then I will halt. Let's run through this. Note the program counter and the accumulator, the contents. So we start at 0. Program counter is incremented and accumulator has a data 2. We add the 3. We store the data at memory location 5, and we output the results, and then we halt. That's the fetch and execute cycle. Thank you.